Okay, we got to boxing and unboxing. In this video, I'm going to talk about the concept of value types and reference types, and from there we'll lead to boxing and unboxing. So all types in C# are divided into two categories: value types and reference types. Value types are stored on the stack. What is the stack? When your program is executed, a limited amount of space in the memory is allocated to each thread of your program. And this space is used to store simple values, like all primitive types like byte, integer, float, char, bool, as well as the struct type. Values stored in the stack have a short lifetime, which means as soon as they go out of the scope, they immediately get kicked off the stack by the runtime. We also have reference types. Reference types are stored in the heap, which is a larger amount of memory. We use heap to store objects that require a longer lifetime. Examples of reference types in C# are basically any classes. So the object class, that is the parent of all classes, or the array class, or the string class, or let's say we have a custom class called dbMigrator. These are all examples of reference types. Now, why does it matter? Well, earlier in this section, we learned that an object reference can be implicitly converted to a base class reference. And here's the example I showed you. So here we create an instance of a circle class, and then we can simply assign it to a shape reference. So this object reference can be implicitly converted to its base class reference. No conversion is required. We also learned that the object class is the base of all classes in the .NET framework. So taking the last example, we can modify it to something like this. So since the object class is the base of all classes in the .NET framework, we can simply point it to any objects, and that object reference will be implicitly converted to the object reference. Now that brings us to an interesting scenario, where we put a value type on the right side of the assignment operator, and this is what we call boxing. So in a formal definition, boxing is the process of converting a value type instance to an object reference. So as an example, here I have a number that is of type integer. And since object is the base of all classes in the .NET framework, we can declare an object variable and assign it a value type, as you see here. Or a different way to write the same code is like this. We simply declare an object variable and assign it a value. What happens behind the scene is this value gets boxed by the CLR and stored in the heap instead of the stack. So let's take a look at the memory visualization. So assuming that here we have a stack and a heap, and on the stack we have a variable called number with the value of 10. Now when boxing happens, CLR creates an object in the heap and then creates a reference in the stack that points to that object. So as you see, the value is now stored in the heap along with an object reference in the stack. Unboxing is the opposite of boxing. So in this example, we have object that is assigned 10. So at this point, boxing happens. Now when we cast that object to an integer, unboxing happens, and the result is we get a new variable on the stack called number with the value of 10. What you need to know about boxing and unboxing is that they both have a performance penalty because of that extra object creation. And that's something you should avoid if possible. It's best to show this with an example. So let's start coding and see boxing and unboxing in action. Okay, earlier I told you about the ArrayList class. Let's create an object of type ArrayList. Now let's take a look at the add method. As you see, the add method takes an argument of type object, which means because the object class is the parent of all classes, we can pass any objects here. So I can pass a number here, or a string, or a date time, or anything. Now there are two problems with the ArrayList. The first one is type safety. As you see, each element here has a different type. So we lose type safety, which means at runtime, if I try to get the second element of this list and cast it to an integer, we're going to get an exception. So let's declare a variable called number and get the second argument of this list and cast it to an integer. Now the second argument is of type string. So if we do casting here, we're going to get an invalid cast exception. So that's one problem with the array list. But there is another problem. The problem is the add method takes an argument of type object, which means if we send a value type here, boxing will happen. And subsequently, when we get that value back and cast it, unboxing happens. So in this example, 1 is an integer, it's a value type, and here we get boxing. String is a reference, and in this case, boxing is not going to happen. And datetime is a structure, as you see here. A structure is also a value type. So again, here, boxing happens. A better way is to use a generic list. So instead, let's create another list and use the generic list here. And let's say we want to store a list of numbers. So we pass integer as a generic parameter. This generic list class is defined in system.collections.generic namespace. And now let's take a look at the add method. So another list.add. Look, it receives an argument of type integer as opposed to object. So we get type safety, which means every element is going to be an integer. And no boxing will happen because internally this list stores a list of integers, not a list of objects. Let me show you another example. So this time I create a list of names and I use a generic list of string. Now if we access the add method, every element is a string. Again, we have type safety and no boxing. So the lesson is, when you're working with a class, if you're calling a method and that method gets an argument of type object, be aware that if you pass a value type there, boxing is going to happen. And this has a performance penalty. It's better to use a generic implementation of that class if it exists. Well, that's pretty much all you need to know about boxing and unboxing. I hope you enjoyed this lecture and thank you for watching.